watching us here, but hopefully this will sound great on your end. Today, we're going to do a real quick webinar focusing on Tsuneishi Shipbuilding, which is an interesting word to say, and we'll be saying it a lot today, so hopefully I won't butcher that too bad. But before we get started, talking about them specifically, I want to introduce a little bit about us. If you don't know who we are, Last Technology is a Japanese-owned company. First and foremost, we were founded in Tokyo, Japan back in '97. Since about 2003, we've had a U.S. subsidiary operating at first in San Francisco and then out here today. Now we are in Colorado, near the Denver area, in a place called Westminster, which is not a terrible place to live. We've got a beautiful view of the Rocky Mountains, where we service all these industries you see on the screen here, working with thousands of customers daily who use our free player to view our content, as well as the many hundreds of companies that we work with throughout the world today. Some of our customers, just to give you an idea of who we work with, but everybody can show you a slide like this. But some things to take note of: we work with Toyota pretty exclusively, with them owning 20% of our company. But we also have companies like Lockheed Martin and their Skunk division. Also work with companies such as Honda, MAN Trucks, Siemens. We kind of run the gamut. But something that is interesting, that all our customers really have very large part count models, and a shipbuilder, as we're going to be talking about today, is a very good example of really what our software can do and the power of XVL. Speaking of XVL, you'll see here on the screen we actually have a XVL model displayed. This is what I like to call a toy tractor, but that's interesting to show you how we can integrate right into PowerPoint. And we also work great within native environments of Siemens products, including NX, Teamcenter, the Solid Edge product, as well as Dassault Systems products, including SolidWorks and CATIA, Creo and the Pro Engineer products from PTC, as well as even Inventor from Autodesk, meaning we support their native file format right within our software. We also offer tools to integrate within their tools to help you export to XVL. We kind of work seamlessly with all these products, and then also including Microsoft Office, which you'll see extensively throughout the presentation. Moving on to the next slide, let's talk about shipbuilding. Let's talk about Tsuneishi. So Tsuneishi is a large company based in Japan. They actually have 4 main factories operating worldwide, 2 in Japan, 1 in Cebu Island in the Philippines, and 1 in China, meaning they are working in a global market. As such, one of the big challenges they have is that they have a very large product. I can't think of a bigger machine really than some of these crude oil carriers that exist, or some of these car carriers that are out there. These are big products that take a long time to build. They also have hundreds of thousands of parts, if not, getting close to 1 million. Many must maintain a high level of accuracy throughout the design phase, as well as through manufacturing. A couple of inches can mean a big deal in a ship. It needs to be watertight. So these are not easy to build. This is one of the most challenging, I think, designs that are out there today. So one of the big things they also face is a challenge that they have the ability to not have a prototype. You can't really build a prototype of a boat like this. We'll explain how they operate without the prototype in a little while. But another big challenge is that in Japan, the labor market is expensive. Building products like this in Japan has become cost prohibitive in a lot of ways. So thus they must move these operations out to the Philippines or China, where the labor market's far more competitive for them to be building these products. So we'll see how they overcame that challenge as well. There are 3 main takeaways I really want you to have from this presentation today. The big really benefits of working with XVL and this built industry was that they were able to find failure early. We want to show you how they do that by front-loading a lot of the design and assembly validation with XVL products. Another thing that they do very well is they validate and plan the best assembly process. The way they do that is using our assembly tools and using XVL to process their model data into a usable size that enables them to run various validation tests on their assembly. So we'll show you how they do that. And then another big goal of many companies today, I think this kind of applies across industry, is how do we overcome training obstacles, especially working in international markets with many different levels of education and levels of language capability. So often we have to get our instructions out to people that don't speak the same language. How do we do that in an effective and usable way? Okay, so there are 4 solutions that we apply with XVL products that really apply to PLM and help, as we say, drive usage of PLM, or how do we improve the uptake of product lifecycle management software as well as the data that's coming out of it. So we have design review, work instructions, assembly validation, and service documents. Again, I'm going to show you a little bit about 3 of these subjects today, but don't forget that we also offer service documents as another output of our software. So to talk about design review, I'd like to talk about the before and after, before XVL, after XVL implementation. Before, and especially in an industry like shipbuilding, they were doing design review with CAD, or attempting to. In this case, Tsuneishi was depending on 2D CAD for a very long time, which really didn't give them effective design review tools, especially when interacting with anyone that was working in manufacturing. Usually at that point it's a bit late to really get in there and do too much design review when you're looking at manufacturing. However, Tsuneishi has found that there's another way to do it. So after implementing XVL, we think that we can front load the occurrence of defects found in design review process by doing it more often, enabling easier design review by having the ability to review very large model size and very large part counts quickly and easily with XVL, because XVL will allow you to reduce the file size on average of 3D CAD about 1/100th of the size of the standard in 3D CAD. So we'll kind of get a little bit further into this in a little bit, but the applicable divisions for design review obviously are design, production, engineering, and production. And the tools that we use from our tool set here are XVL Studio series. You'll see them all marked in green here, meaning XVL Studio Basic through Pro. Also, Last 3D Reporter can be used. And the applications for those 2 products are measurement, sectioning, annotation, and even annotation for design feedback to the design team. So find defects, we can highlight them, annotate them, and send them back using the annotation view function. Design validation tools are also usable in this phase. We find that XVL Studio Pro, with its dynamic interference checking ability, is very useful, as well as the difference check option, which is available for all versions of Studio. It is an upgrade, but it does display the differences in 3D geometry, giving you an effective way to review the changes without words in a way that is very effective in really seeing the differences between 2 design iterations, if you will. Moving on to assembly validation. Again, this is applicable to design and production engineering departments. The old way of doing things was, going through this linear, repetitive process of design, prototype, evaluation, finding defects, and restarting your design, going to a new iteration and doing more prototyping, evaluation, and then restarting this process over and over again sometimes. We find problems a little too late this way. Again, in this case, we're not even able to do the prototyping. We have to really get it right the first time when it comes to shipbuilding. So the way that it works with XVL is a little bit better. We're able to reduce the number of prototypes, in this case, hopefully eliminating prototypes, getting them right the first time by doing proper assembly validation, by planning our assembly process as early as midway through the design phase, and then reducing lead time and getting products out to market faster. We'll show you why that's so important with this customer in a little bit here. But the tools that we use for assembly validation solutions, or assembly validation in general, is we use XVL Studio Standard, where we're presented with the ability to have a structural tree, which is the design tree directly from the 3D CAD model, as well as a tree or a BOM, if you will, for manufacturing, and one that's also for process. These are all interlinked, meaning that you select one, you see the parts in the other, allowing you to validate that all your parts are there in your process, and also that they're there in the right order for procurement or for assembly purposes. It's a very, very effective tool.
And Eric, let's ask a poll question here quickly.
Sure.
So this is specifically about validating your assembly process. So if everyone could just take a moment to answer this. So are you just use your CAD system, or you're validating by building physical prototypes and then making sure everything fits together in tolerance, no collisions, and you can get a part in and that? Or do you use a specific software solution like Lattice technology, or perhaps you have something else? To give you guys a few more seconds here, and we'll close the poll. And here's the results. So split between using your CAD system and a specific solution like Lattice, and a lot of people with prototypes. Okay. Eric, back to you.
Yep. Thank you. So continuing on, sorry if I'm kind of motoring through this, but we have a lot of content to cover today. So I wanted to just kind of review, again, which products are usable for each of these things so you understand sort of what Tsuneishi did. The lack of content we've gotten from them is one of the reasons that I'm having a hard time to show you specifically what they do, but that's understandable for most companies we work with. They're just not going to share everything that they're doing. Their intellectual property is difficult to show everyone, but we do have some content we can show you. Again, assembly validation tools that are also usable in XVL Studio Pro and Lattice 3D Reporter are dynamic interference and dynamic measurement checks. These are great for detecting problems way early in the process, hopefully eliminating again errors in your process where you have collisions or fit issues. Again, another tool that's usable for this is a human option, where you can sort of human model into your assembly, checking for the same kind of issues, and also in making sure that ergonomics are not an issue, as well as working visibility is not an issue. All of these tools have actually been implemented by Tsuneishi and other companies that we work with to really kind of take advantage of front-loading their assembly validation. So another big issue, or big area that Tsuneishi is really kind of focused on is training. Again, when you have companies that are looking at working overseas with different languages, it's very important to be able to communicate with as few words as possible. So the old process really just doesn't work. It's or very, very cumbersome when it comes to getting your instructions across to a different language, or to a way of someone who maybe doesn't even speak or write or read in a language. So we have the ability here to communicate with as few words as possible using 3D data instead as a source of our content for training instructions or work instructions. In this case, XVL is implemented to create these things instead of using traditional methods such as artists or hand-drawn instructions. And we can show you a little bit how that works, but if you need a further instruction on our capabilities in this regard, we will definitely be happy to set you up with a demonstration. But the return here is that we are able to really create easy-to-understand visual work instructions by using 3D content instead of traditional artists or photographs, and we can really get ideas across in a very effective manner that's also updatable. It doesn't lose the changes that happen from engineering. We can actually push those all the way through to the end product. So in this case, here's an example of the tools we use: Lattice 3D Studio Standard, 3D Reporter, Webmaster, which is our publishing tool for creating HTML content, can all help you create multi-language work instructions or training instructions. Last 3D Reporter, XVL Webmaster, and XVL Publisher also can help you push out that content to Excel, to HTML for the web, or to an iPad, or even 3D PDF. The last part is the last 3D Reporter or Webmaster, and the template option can help you develop templates for different types of content for process planning or for parts lists that can also take advantage of those multi-language capabilities. So let's talk about shipbuilding. I know that was a lot to kind of swallow there from the beginning, but the shipbuilding process is a long one. I can guess that most of you would be able to guess that, but in the case of Tsuneishi, we're looking at about a 2.5 to 4.5 year build process for creating their ships. So that's from PO from their customer to delivery. We're looking at sometimes as long as 4.5 years. So speeding that process can be a really big boon to their business. So we, wanted to see how we could tackle this process, the step-by-step, lengthy build process, and we were able to do so in a very effective manner by tackling a few different areas. So the problems that we saw in the way they were doing things today were that they were doing too many revisions of their design, and the failure of the building, or their failures in the area of finding issues were really hindering their development and design process and getting them to go back to the drawing board several times before they could get out and start building what they call the TESS, or Tsuneishi Economical Ship or Standard Ship. This ship is really the template for all of their builds for as many as 100 to 400 ships come off this one base model. So the essential idea here is that they will build this TESS one time, get it right the first time, and they were trying to do this in Japan from the get-go, and then use this template to then customize and deliver ships that are based upon the TESS that met their customers' needs. So the first build is essentially very critical in their process. What they started to see is that doing this in Japan didn't allow for them to really effectively work. So they started doing this in every facility that they run. So overcoming the language barrier was essential to really getting this done the correct way. So they're working in the Philippines as well as China, where the worker was not nearly as skilled as they were in Japan. So this challenge became a very critical challenge to overcome, and we'll show you how they did that. But creating these easy to understand work instructions became not only a desire of them, became a necessity for them to be successful. The XVL solution came in, and instead of really replacing 3D CAD or doing anything of groundbreaking nature, we really kind of came as a tool that could accentuate what they were doing in 3D CAD and then really take advantage of what they were doing in 3D CAD, because the 3D CAD came at the same time almost as XVL did. They decided to really go all in with 3D, but they found the same issues that most of our customers do, is that 3D CAD didn't deliver the usability when it came to working with the large part counts that they did, that they needed. They're looking at hundreds of thousands of parts at the same time. They want to be able to review their assemblies. Using XVL allowed them to front load that ability in development and design process, as well as use it down the line in assembly and outfitting phases of their product life cycle. So in review, really what they found was that the current workflow has now allowed them to take advantage of XVL in a way that design issues can be found earlier. They're taking their CAD, they're converting it to XVL as soon as possible, and they're doing their design review, giving feedback to design where the CAD is being used to update that design, and this is somewhat of a circular process here, but it allows them to work quickly and efficiently with very large part counts and do the review in a visual manner rather than having to rely on words. So design is taking place in multiple facilities. They're all cooperating with one another despite language barriers, using as very few words as possible, and getting this design right and this process of assembly right from the get-go. An example of that is down here on the left. You'll see one of their what they call sections of the boat, which are very complicated weldments and piping projects that are doing almost everything exclusively in 3D. So they're able to review this design in 3D as opposed to where the generations before them were relying on 2D documents that really didn't allow for unskilled workers to come in and be able to visually understand what was going on. So with that, I kind of want to show you a little bit of what they were able to achieve in terms of a section of the boat build. So this here is actually an animation delivered in XVL of their process. I'm going to start it from here. It's actually, we can go back to the beginning and see if we can get an idea what we're looking at here. I don't know why it started there, but we've got a panel here, the hull of the boat. As we press play, you'll see some assembly process taking place. Essentially, I'm using this tool the same way they would be able to use it, or the worker would be able to use it, pausing it, reviewing what's going on as these parts come in, and then restarting the animation, viewing this build of a section as it takes place. Again, this is really from Tsuneishi, so this is industrial use of XVL. It's not cleaned up or changed by us at all. It's how they use it. So as these sections come in, you'll see that this is a very clear way of understanding how the process of building this section should take place. Not the flashiest of animations, but it is something that is really from them and how they use this product. So at that, I think we're just about at our limit here. Mark, do you have a last polling question for everyone?
Yeah, so let's ask this polling question. I think you guys should see it now. So specifically about work instructions, so distinctly different than the validation process, but how do you document the work instructions that are on your shop floor? Do you have specific use software like XVL Lattice technology, or are you creating documents just as you would create just kind of any document? The numbers are pretty split. Give it just another second. And while this is wrapping up, I'm going to check to see if anyone has any questions. Please put those out into the questions. I'm going to close this poll. And let's see. I don't see any questions. What I would like to do, well, first of all, thank you very much for taking some time out of your day. When we close this webinar, there is a 3-question survey. If you could just take another moment to complete that. And then I will be sending out a link to everybody that has this recorded webinar that you can refer back to or share with anybody else in your organization. So with that, thank you very much. And Eric, thanks for your time today.
One last thing, Mark, I'd like to add, this case study of Tsuneishi is also available through us if you haven't received it yet. So we'd be happy to send that to you as well. So,
yeah, good point. We'll include that in the email that we send out. Very good. Thank you.
Right, thank you, everyone.